This important product rule in calculus had to be understood. Why is that true? So I will provide this diagram. All this thing is given in the test, and you just have to calculate the derivative. All right? All right, first function f of x is given, g of x is given, and the product rule is about f of x times g of x, right? But product rule says if you know derivative about this one and that one individually and separately, you can calculate the derivative of the product, right? That's what it says. So you look at separately. Here's f of x chart, a graph. Here's g of x chart and graph. We're going to analyze the derivative situation and relate it back to this product. And that's going to be the proof. So this whole thing is given. In the calculation of a derivative, we used h, right? 1 over h. But we're going to use now delta x. It's a compound notation. It's not delta times x. It's how much this x variable changes. Small amount. They use this Greek letter delta x. It's one notation. And this f of x is now labeled y. How much f of x is changing is going to call delta y. And the g of x is not going to be y, distinguished with a different letter z. Then how much gx is changing is going to be denoted by delta z. Right? Let's think about the derivative of f of x. It's 1 over f of a 1 over h, f of c plus h minus f of c. Remember that thing, right? And then you put limit h approaches 0 there, right? That's what we did. But this how much this function value changed there is going to delta y. Y is f of x. So this is before you hit the limit, is delta y divided by delta x. What happens to that guy as h approaches 0? Do you know? Where does that one go? Which is equal to that one, right? It's abbreviated notation. This one is supposed to be f prime of c. Thank you. F prime of c. Isn't that what this one as upper h approaches 0? That's the very definition of a derivative, right? Yes, sir? Delta x over delta y. Which one over here? It's not over delta y. This is called delta y. All right. Okay. Good. Good. Does that make sense? All right. Over here, z represent how much a g function is changing. So what happened to that one as h approaches 0? What is this one becoming? G prime of c. That's the very definition of a derivative of g of x at c. Remember? Right? Okay. And from there also we have nice thing you can write down. Can you solve this thing that's equal to delta z and equal to delta y? Can you solve that for f of c plus h? According to if this difference is equal to delta y, what is this f of c plus h? Do you see that is f of c plus delta y? You see that? Yeah, it is equal to that. If you add f of c both sides, you have f of c plus h is this, right? How about here? What do you get? G of c plus h is equal to g of c plus delta z. Thank you. That's that. All right, this is all you need from individual analysis. Now we have to enter the derivative of f of x times g of x, right? So this is something you probably have to memorize if you have to reproduce one. This is a magic line. Consider 1 over h of what now, right? 1 over h of now. This is something to remember. The function we are about to differentiate is a product of the two functions, f of x times g of x, right? So this is how it starts. F of g of minus f of g of. All right? Okay. Do you know what goes into this slot here? C plus h, thank you. C plus h. How about here? Same C plus h. That's the one function. Everywhere there x is, C plus h go in there. Thank you. That is correct. How about the other Remaining two slot. What are those? Just to see there and there. So does it look like this is a function where C plus H is plugged in? This is a function as a product everywhere X, C is plugged in, right? So I hope you see that this is the derivative of the product as H approaches 0. Fair enough? Yeah. Yes, a question? Yeah. That's right. We're going to use that, but it is the first approach. That's exactly right. That's what we're going to do. Yes. Fair enough? Like Noah suggested, we're going to replace this one with this sum of the two things in there. And it's going to fall out as you expand it, and there's nice cancellation. All right? So let's see that. All right. 1 over h. Instead of h, I'm going to change it to 1 over delta x. Is that okay? We have a new name for that h now. It's called delta x. Just new name. All right? In there. So what is that we just said? F of c plus h is replaced by f of c plus delta y. So f of c plus delta y. How about g of c plus h? It's replaced by g of c delta z. Isn't that right? Minus f of c times g of c, correct? This is not an official exercise, but the next step is the important moment. You feel the product rule right there. What is happening to the product rule is explaining in this process. Not an official exercise, but I want you to go ahead and expand this one on your own and write it down and cancel if there's anything that cancel out, right? There are two terms and two terms. If you multiply out, you're supposed to get four terms, right? Product of one term, another product of one term, two things multiply, and the third term a product of two terms, fourth term product of two terms. So you have four things added together, and one more thing out there, FCGC. All right, how was it? I wrote it down like this: f of c plus delta y, underneath it g of c plus delta z. All the terms must be multiplied to the bottom row. fc multiplied there and fc multiplied there. Delta y multiplied there and delta y must be multiplied to delta z. So 1, 2, 3, 4 terms fall out. Fair enough? Do you see cancellation? F of c times g of c cancel with f of c of g of c. Cancel out. All right, so proceed. Now we have delta x, fc, delta z, plus delta y gc plus delta y times delta z. That's the analysis. Isn't that right? Okay. Next thing you do, you're going to distribute this delta x everywhere. And there's a moment. See, if you just multiply this one, you can see you can group this one together nicely like that, because we know something about delta z divided by delta A. Does anyone know about delta Z divided by delta X? Yeah, that is becoming G prime of C, right? That's why I grouped it like that. That is also distributed here, delta Y divided by delta X, right? Do we know anything about delta Y divided by delta X? That is nicely becoming a quantity F prime of C, right? Now, and there's a GC out there. And I don't know what to do with this one, so I'm going to group it like this, delta Y divided by delta X, and you have to leave that delta Z out there. Make sense? Think about why I grouped it like this. Because you know what's happening to this quantity, right? It's no longer in determinate form. We have information. How about here? We know what's going on in there, right? So we know where it's approaching. How about here? That's good. How about the last one? Does anyone know what happened to delta Z? Do you have a question? Why didn't I put this one over the delta Z here as well? You think about it like this. Is a 5 times 3 times 2 is not 5 times 3 times 5 times 2. It is only 5 times 3 times 2. It doesn't distribute. If it is 5 times 3 plus 2, then it's distributed like that, right? But if it is 5 times 3 times 2, like that, it doesn't distribute, and that's what it is. The delta X does not distribute over the two things, only one thing in there. Does that make sense? Right. If you distribute it here, that delta X approaches 0, right? It goes to like infinity, but delta Z is approaching 0, is indeterminate form. But if you put it underneath it in here, we know what happened to delta Z divided by delta X, right? Because we have information, delta Z divided by delta X, delta Z approaches 0, delta X approaches 0. 0 divided by 0, what is it? Approaching 0 divided by approaching 0 is an indeterminate form, right? But we do have more information than that. That's why we grouped it like this. That was your original question. All right. Apologize. And here as well. If you put delta X underneath it, it's a wrong information. It is not like undefined. It is incorrectly organized information to get to the conclusion. But if you put it in there, correctly organized, so that you have information out of that. So next step, use this 3-letter you have long forgotten called BLP, right? By BLP, f of c, there's no delta x in it, right? F of c is just f of c. What happened to that guy? Delta z divided by delta x. Where does it approach? G prime of c. Thank you. How about this one in here? F prime of c. How about this one in here? Not changing at all. It's always there, right? So G of c. Next one is peculiar. How about this one in here? F prime of c, right? How about delta z? Who remembers anything about delta z? Delta z, as delta x approaches 0, is a small quantity, right? So that approaches 0 there. Does that make sense? Yeah. Delta x approaches 0. Because of that, delta y approaches 0. Delta z approaches, all of them approach 0. And that's why this is interesting. Approaching 0 divided by approaching 0. Isn't that undefined? No. It's indeterminate form. That information alone is not enough. But we have more information that was sketched in the picture that actually approached this number. So it's no longer indeterminate form to us. All right. So how does that simplify? F of c times g prime of c plus f prime of c times g of c. I want you to stare at that. And what just happened? We proved the product rule. We proved the product rule. So guy in the street grabs your arm really hard and then pull it to you and ask, why is the product rule like that? If that guy asks, what is your quick answer? Oh, you see that little term multiply across it and they survived. Right? That's a one-liner. Right? That's my first guy in the street joke in this calculus course. Right? So go back to the, why does it look like, why does the derivative rule work like that? It just cross multiplied and they survived in this way. Fair enough? Right.